Welcome Honors Algebra 2 and Algebra 2 students. Mrs. Fallon here. We are starting Unit 10, which is all about probability. And so in this unit, we have to kind of get started with a bunch of vocab so that we understand what it is that we're talking about when we talk about different things like outcomes, events, or sample spaces and stuff like that. All right, so let's go ahead and kind of dig into it, and then we're going to go through some examples, so some problems just to kind of hopefully help this make sense. If you haven't already, you will need to print off, if you can, the 10.1. It's like basically it says like extra notes. So rather than the examples that I want to go through, I'm going to use ones that are different than in our student journals. And so the ones that I want us to kind of go through are in kind of a separate packet. So if you could please print that off. I might have some hard copies for those who are in class, but if you don't have that already, just at least print it off so that you have them available. So that way you're not kind of writing down the whole thing. All right, so probability experiment. So basically this is the likelihood that an event will occur. So this is like a trial or an experiment. Okay, so like imagine that you're doing a trial. You're spinning a spinner, you're conducting a survey, something like that. It's the likelihood that the event will occur. So we're going to see this a lot. And so basically what we're going to talk about is just kind of like the probability of something happening is basically kind of what we're getting at. All right, an outcome. It's a possible result from an experiment. So think of it as, so it's a result from an experiment. So again, if you were, let's say, rolling one die, right? So an event or an outcome might be that you rolled a 6. So 6 would be your outcome, or 2 or whatever. So what they're looking for is whatever the experiment is, whatever you get as your outcomes, as your whatever happens in the experiment is what we call an outcome. An event is a collection of one or more outcomes. See, a collection of one or more outcomes. So, for example, if you were rolling a die, right, an event might be the probability or the chances of you rolling an even number. So if you roll a die, obviously there's more than one opportunity to get an even number. And so that would be a collection of one or more outcomes. You could roll a 2, you could roll a 4, you could roll a 6, right? Those would all be even numbers. And so that collection, the probability of rolling a 2, a 4, a 6 would be an event. A sample space is a set of all possible outcomes. So again, if we're going to use my example of rolling a die, your outcomes would be you could either roll a 1, 2, 3, 4, 5, 6. That's it. So there are 6 particular outcomes in your sample space. So there's a limited number of possibilities that you could choose from, right? So there's only 6 possible outcomes, and that all 6 of those together are considered a sample space. All right, so the probability of an event, this is mostly what we talk about. So the probability of an event is the likelihood or chance that an event will occur. So let's write that down. The likelihood or chance that an event will occur. So what is the probability? A lot of times you'll hear that kind of word kind of given. The probability of rolling an even number. Well, if the sample space is 1, 2, 3, 4, 5, and 6, right? The probability of rolling an even number, you could get a 2, a 4, a 6. There's 3 chances out of 6, so the probability would be 1/2 because it's 3 out of 6. So again, that's just kind of a basic example, but that's kind of what we're getting at. All right, so theoretical probability. Basically what we mean is that all outcomes are equally likely to occur. There's a theorem for like theoretical probability. So let's do this formula actually. It's the number of favorable outcomes. So number, that's supposed to be number of favorable outcomes over the total number of outcomes. So again, let's use my example with the even number, right? So the number of favorable outcomes, so rolling an even number, there's 1, 2, 3 choices, right? So that we got 3 out of total number of outcomes. There were 6 possible outcomes to choose from, right? There were 6 possible chances. So a theoretical probability is the statistical or mathematical probability that something will occur. Okay, so it's the number of favorable outcomes over the number of total possible outcomes. And one of the caveats here is that you have to remember is that each of those outcomes have to be equally likely to occur. So these outcomes are all equally likely to occur. And so obviously if one outcome was favored more than another, if it was not equally likely, then that would change our probability. All right, geometric probability. So geometric probability is, it's found by calculating a ratio of 2 lengths. So it's the ratio of, could be 2 lengths. So like think about the ratio of width to length. Could be the ratio of 2 areas, or the ratio of 2 volumes. So we're gonna get into a couple where I'm gonna give you kind of like the traditional one that you see is like there's a dartboard and like certain parts are colored in. What's the probability of landing in, you know, the red section of that dartboard or something like that. And so we're gonna go over a couple examples of that, but that's kind of what they're getting at. All right, experimental probability. That's a little bit different based on, so experimental and theoretical are the 2 types of probabilities that we kind of get into. I mean, obviously geometric is in there as well, but these are the 2 main. So it's based, so an experimental probability is based on repeated trials, okay, of a probability experiment. Okay, so what this is basically over is it's like saying we're not going off of the mathematical probability that's going to happen. Like we know the mathematical probability of rolling an even, if I roll 1 die, right, 1 6-sided die, the theoretical probability of me rolling an even number is 3 out of 6, or in other words, 1/2. That's the theoretical probability. Let's say you rolled a die 10 times. And on those 10 times, you got 8 out of 10 that you got an even number. So this is 4/5 if you reduced it, right? This is a different probability than what you got as theoretical. This is based off of an experiment. So, and this is based off of a theoretical. Like in other words, I don't want to say the true, but it's based off of the mathematical possibilities. So experimental probability is literally based off of something that's like that you do an experiment on. Sometimes it's the same as your theoretical probability, but sometimes, like in my scenario here, it's a little bit different. In general, the more times you do an experiment, so let's say instead of rolling the die 10 times, you rolled it 100 times. The more times you do an experiment, the closer the probability will get to the theoretical probability. Because over time, all that error and chance kind of averages out. So experimental probability, what you need to know about that is really just that it's based off of an experiment or a trial. So you can kind of write it as an or as a formula if you want. So experimental, I'm just going to probably abbreviate here. Experimental probability is the number of successes. So like in our scenario here, it would be the number of times you got an even number over the number of trials. So like, for example, I got an even number 8 times out of 10 times that I rolled the die. So number of successes over number of trials. All right, let's talk, let's go a little bit at the bottom here. This is called probability of a complement of an event. Probability of the complement of an event. So the probability of the complement is basically what this little, so P sub A means the probability of A happening. So what I mean by that is like the probability of me rolling a 4 when I roll a die. So it's the probability of whatever A represents. If A represents rolling a 4, it's the probability of rolling a 4. If A represents the probability of, it raining outside, on any given day, then that's the probability of it raining. So A represents anything you want it to represent in your probability statement. The probability of A bar, so there's this bar over it, and what this really means is not A. In other words, it's like in our scenario with, the 4. The probability of 4 would be probability of A. Probability of not 4 would mean basically the probability of rolling anything other than a 4. If I said the probability of it raining, then the probability of A with the bar over it, which is called A bar, real original there, but if it's called A bar, that would be the probability of it not raining, right? So it's kind of like the opposite, or the whatever's left over. So like, for example, if I did 1 minus the probability of A. So if I knew that the probability of rolling a 4 was 1 out of 6, right? So if I roll a die, it's 1 out of 6. And so the probability of not rolling a 4 would be 100 minus, or 1 minus 1/6. Or in other words, 1 minus 1/6 would be, 6/6 minus 1/6 would be 5/6. So the probability of rolling A, the probability of rolling a 4, which is A, would be 1/6. The probability of not rolling a 4 would be 5/6. So all you're really doing is subtracting it from kind of a whole, right? So you're thinking about 100% taking away the probability of something occurring. So let's take a look at a couple examples. So one in particular says the probability of it raining today is 60%. The probability of it not raining is what? So again, what I'm kind of looking at here is if the probability of raining, so if rain, the probability of it raining is 60%. And then the probability of not rain would be 100, or 1%, minus 60%. So you can think of it as 1 minus 0.6, or you can think of it 100 minus 60. Either way, you're going to get 0.4, or in other words, 40%. So the probability of rain is 60%. The probability of not rain would be 40%. I just kind of want to walk through a little bit as I'm going to kind of squeeze this in on this page here. But I just kind of wanted to, again, kind of go through that example of rolling a die. So we have one die, right? And so again, this is a 6-sided die. I know that there are other different kinds of dies out there, but there are each of these events, okay, 1, 2, 3, 4, 5, and 6. Each of these are considered an event, right? Each of these are considered an outcome. An event would be, one or more of these happening. A sample space represents all of the possible outcomes. So that's all of these possible choices here. Let's say I then said, okay, what's the probability? Let's do an example of what's the probability of flipping a coin and then rolling a die. So let's look at flipping a coin. So flipping a coin, you have 2 choices, right? So let's think of it. You have heads and you have tails. So if I flip a coin, I get 2 choices. Then if I flip a coin and then roll a die, what else do I have? Well, if I flip a coin and roll a die, I could get 1, 2, 3, 4, 5, or 6. I could get heads, and then I could get 1, 2, 3, 4, 5, 6. Same thing with tails. I could flip a tails, then I could get 1, 2, 3, 4, 5, 6 if I roll a die. So this is kind of our possible outcomes given our scenario. So the total sample space would be, I could get heads and then a 1, heads and then 2, heads and then 3, heads then 4, and then 5, and then 6, right? So those are all possible, each of those are possible outcomes, but together they make a sample space. Same thing with tails. Tails 1, I'm gonna try to squeeze it in here. Tails 2, 3, 4, 5, and 6. So together there are 12 possible outcomes in my sample space. So if I did 2 things together, so not just rolling a die, there was only 6 possible choices. But if I flipped a coin and then rolled a die, now I have 12 possible choices. So one of the ways to look at that is if you look at the probability of rolling, of flipping a coin, there are 2 possible outcomes. And if you look at the probability of rolling a die, there are 6 possible outcomes. To get the total number of outcomes in your sample space, all you really need to do is multiply those 2 outcomes together. So if you're flipping a coin and rolling a die, it would be 2 times 6, which is 12. Let's say I was rolling a die and then rolling another die. So there's 6 choices in the beginning and 6 choices at the second time. So 6 choices when I first roll the die, 6 choices when I second roll the die. That means there are 36 possible outcomes. So again, if you're looking for the total number of outcomes, all you're really doing is multiplying those together. All right, what I'd like you to do is kind of grab that packet that I was telling you guys about. I want to go through a few examples together, and that way we're going to do some practice with this in class, but I wanted to go through together just so you have it on video and so forth. All right. So you spin a spinner, flip a coin. How many possible outcomes are in the sample space? List all the outcomes below. So this is what I was kind of getting at, right? So you spin a spinner. So there's 1, 2, 3, 4. Notice that they're all the same area, so they all have the same probability. So if you do a spinner, right, you have 1, 2, 3, 4 possible choices. You could get a 1, a 2, a 3, or 4. And then you flip a coin. So for each one of these, you could get a heads or a tails. For each one of these, you get a heads or a tails. So this is just kind of a tree chart, which is basically just a way to kind of organize your data. This means that our sample space is the list of all of our outcomes. So I could get a 1 on the spinner and then a heads, or a 1 on the spinner, then tails. And then same thing with 2, same thing with 3, same thing with 4. So it says list all the outcomes below. These are all of my possible outcomes. So what I was doing above here was just a way to help organize. And again, if you were looking at mathematically, there were 4 choices to begin with, and then choices on the second time. So 4 choices on this, 2 choices for flipping a coin. Together, that needs to give me 8 possible outcomes. So again, that's how many total outcomes I was looking for. All right, let's look at the next one. Find the probability of each event when 2 6-sided die are rolled. All right, so let's think about this first and foremost. If I have a 6-sided die, so that means I have a 1, a 2, a 3, a 4, a 5, and a 6. And then each one of these, I have a 1, 2, 3, 4, 5, 6. Right? So each one of these, I can get a 3, then a 1, a 3, then a 2, a 3, then a, So again, what we're getting at here is there are a lot of possible choices. So it's not always feasible to write them all out. Now you can, in this case it's not too bad, but when we get a little bit larger numbers, it's not going to be as easy. So what I'm getting at here is these are all the possible outcomes. So if I have 6 choices on the first one, 6 choices on the second one, I have 36 possible outcomes. So that's what I was getting at when we were talking about that earlier. So what's the probability that I get a sum that is greater than 8? Okay, so again, greater than 8. Well, if I add 1, 1 plus 1, 1 plus 2, 1, 3, 1, 4, 1, 5, 1, 6, none of those sums would be greater than 8 because the largest one would be only 7. With 2, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, nope, 2, 6 would equal 8, right? 2 plus 6 equals 8, but it's not greater than 8. So I have no choices here. None of those outcomes kind of met my criteria. None of the outcomes here. Let's see how many of these outcomes meet my criteria. So 3, 1, 3, 2, 3, 3, 3, 4. 3, 4 is 7. 3, 5 is 8. That doesn't work. 3, 6 is 9. So there's one outcome where I have a sum that's greater than 8. Let's look at 4s. 4, 1, no. 4, 2, no. 4, 3, no. 4, 4 is 8. 4, 5 is 9. 4, 6 is 10. So that means there's 2. And then for 5, let's see here. We got 5, 3 is 8. We know the other ones don't work. So 5, 4, 5, 5, 5, 6. And for 6, I've got 6, 3, 6, 4, 6, 5, 6, 6. So the sum is greater than 8. What's the probability that the sum is greater than 8? So we're looking at the theoretical probability. So this means we're looking at the number of favorable outcomes. So in other words, what we're looking for over the total number of outcomes. So in our scenario, we have 4, 7, 8, 9. We have 10 favorable outcomes. out of a total number of outcomes of 36. So in our scenario, our probability is 10 out of 36. I would call this 5 out of 18. And you could even write that as a percent or a decimal if you wanted to. All right, what's the probability that the sum is not 2? So in our scenario here, sometimes it's easier to think about what the probability would be rather than looking at how many times it's not 2, because there's quite a few options here that are not 2. If we looked at the opposite, so if this represents probability of A, I'm going to give you a scenario in which we can use the probability of not A. In other words, this represents the sum is 2. Okay, so if probability of A represents the sum is not 2, probability of not A represents the sum is 2. It's kind of easier to look at how many times we can get a sum of 2 than it is to look at the number of times we can get a sum that's not 2. So let's look at the sum that is 2. Well, I only have one choice here, right? 1 and 1. So I'm just going to put like a little tally mark. Do I have, 2 plus 1 is going to give me a sum that's 3. I don't think I have any others, right? There's no other choices here that gives me a sum that is 2. There's only one choice. So according to our probability of not A happening, it would be 1 minus the probability of A, which means 1 minus, there was only 1 out of 36 choices that would give me a sum that is 2. So let's do the math here. 36 out of 36 minus 1 out of 36 gives me 35 out of 36. And so if we wanted to write that as a decimal, so take 35 divided by 36, I get approximately 0.972. So there's a pretty high percentage, right? It's about 97.2% that I'm going to get a sum. If I roll two die, right, that I'm going to get a sum that is not 2. Get a sum that is not 2. So that might be a scenario in which you'd use that whole not thing. All right, let's do a geometric probability. So in the geometric probability, we're looking at the ratio of like area over the whole thing. So like you throw a dart at a board, your dart is equally likely to hit any point inside the square board. So it's a square board. That's a key part right here. What is the probability that your dart lands in one of the two yellow sectors in the small circle? Okay, so first of all, this was supposed to be colored. And so these little like gray pieces here are considered our yellow sections. So just kind of use your imagination on that one. So the probability that your dart lands in one of the two yellow sectors. So when you're doing a geometric probability, you want to look at, again, kind of like the probability of your favorable outcome over the total, okay? So the probability of my favorable outcome, I need to find the area of this little sector here and this little sector here, okay? So what this actually equals is half of this circle, right? If you put those two little things together, those little pieces, you get half of this little circle. So the formula for circle is pi r squared, but I want half of it. So I'm going to do 1/2 pi r squared, okay? The total is a square, okay? So this whole thing is a square. How do you find the area of a square? Well, you do side squared, or length times width, either one. All right, so let's plug in some numbers. So 1/2 pi times r squared. So the radius of this circle is 2 over the side squared. So like, what is the length of this side? Well, let's do a little work here. We know this little piece is 2 and this little piece is 3. That means our whole radius, so from the center out to the edge, is 5. That means that my square, if this piece is 5 and this piece is 5, that whole thing is 10. And since it's the square, every side is 10. So 10 squared is 100. So let's do the math. 2 squared is 4, half of 4 is 2. I get 2 pi over 100, or in other words, pi over 50. So if I do that, I get approximately, let's do the math here. Pi, so use the pi button on your calculator, not 3.14, divided by 50, and I get about 0.063, which is, if you change it into a percent, is about 6.3%. So the probability of landing in this little region here or that region here is only 6.3%. Okay, we have a couple more. So number 4, a spinner has 5 sections colored red, green, blue, yellow, purple. Each section of the spinner has the same area, so that's important. The table shows the result of 50 spins. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So again, experimental probability is based off of an experiment, which is there. Theoretical probability is based off the probability of something happening, like, right? So like the mathematical equivalent. If we have 5 sections, right, and there's red, green, blue, yellow, whatever, all of them. So we have 5 separate sections. So I have red, green, blue, yellow, and purple. Each one has since they all have this area, each one has the same theoretical probability. It's 1 out of 5. That's your theoretical probability. Okay. Experimental probability, we have to do a little bit of work. We know that we have 5, 20, 3, 10, and 12. So we have to know how many times we spun the spinner. So let's add up all these numbers. So if I do that, I get 50. So the probability of red in my experimental probability would be 5 out of 50, which if I reduce would be 1 out of 10. Obviously, this is not the same as that. So the probability of green would be 20 out of 50, which would be 2/5. Again, not equivalent to 1/5. Probability of blue would be 3 out of 50, and that doesn't reduce, and that doesn't equal 1/5. Probability of yellow is 10 out of 50, which reduces to 1/5. If you notice, those are the same. Let's check purple. Probability of purple would be 12 out of 50, which would be what? 6 out of 25. Either way, that's not going to give us 1/5. So, and which one has the same probability, the theoretical probability, as it does experimental probability? And the answer would be yellow, because those probabilities are equal. Remember, just experimental probability is based off of an experiment. All right, last, number 5, use the data display. What is the probability that a pet-owning adult chosen at random has a bird? So in there, this is a bar graph, okay? And so what we're looking at is we have all the different numbers of pets. So we have 916 of these people surveyed. So this is like an experiment, right? 916 have a dog, 677 have cats, 146 have fish, and 93 have birds. And so total, we have 1,832. Now we're not counting like the number of people who have both, right? Because like I have a dog and a cat, for example, but we're not looking at that. So it says, what's the probability that a pet-owning adult chosen at random has a bird? Well, the probability of a bird would be 93, because that's the number of favorable outcomes, over the total number of outcomes, which would be 1,832. So if I do the division here, I get 0.051, which is roughly, if I make and move this decimal place over 2 spots or multiply by 100, I get about 5.1%. All right, so this probability unit, some of you guys will probably find this to be very easy because it just makes sense. I am not one of those people. I tend to have to think about some of these problems. So if you're struggling on this, you're not alone. It does get confusing. So I encourage you to practice. I'm going to give you some practice on big ideas, and we're also going to practice in class. Again, if you haven't printed this off yet, we're going to be using this for every section of notes. So go ahead and print that document off. All right, bye for now.